Okay, welcome everybody to on board. Welcome to the platform. I really want to appreciate you first of all for taking your time to be on the platform at this moment. And before I continue, I want to make sure that I'm not talking to myself. Please, if you're there, kindly confirm that you're hearing what I'm saying. Can you hear what I'm saying? Well, please, somebody confirm that they can hear what I'm saying.
Yes, we can hear you.
Okay, thank you very much, Mr. Kasacha. Yeah, I want to welcome everybody to this session of today. Those who have been live with us on the platform have been seeing and the discussions. This is an on-demand technical session derived from the last session that we had, and it is very important that those who were here last time still can be able to understand our sessions that have been going on. And regarding today's topic, remote sensing and raster data analysis, yes, we want to make sure that we get the very best. And without taking much time, I would like to introduce the facilitator of today, Madam Aisha, then also give a small abstract about the technical session we are going to be having today. Then from there, I will be opening up the floor direct to Madam Aisha without even taking any other minutes. And above all, you're all welcome on this platform. Without further ado, I will just make you aware of the facilitator we are having today in the house. She's called Mrs. Aisha. Mrs. Aisha Nanteza, who is a GIS expert with over a decade of experience in spatial data analysis, remote sensing, GNS, geodatabases, and using ArcMap, QGIS, Serapac, Datamine, Rockworks, and Oasis Montage, majorly focusing on improving all their spatial analyst toolboxes with the help of Python and Model Builder. In addition to that, she is passionate about big data analysis, virtual and augmented reality in improving real-time spatial solutions, map projections, and advanced geodata visualization and map animation. She is a proud geologist with a backbone in base metal, nickel and copper, and gold exploration. She is highly competent in core logging, geotechnical logging, mapping, resource estimation, geological report writing, and presentation. She is currently pursuing a Master of Science in Geographical Information Systems and Technology from Makerere University. Aisha is also affiliated to the Geological Society of Uganda and the ISU under the Mining and the Hydrogeology chapter. Above all, before I go ahead, please, I want to really appreciate our sponsors of this session. I want to appreciate IDEA. I want to appreciate the collaboration from the Geological Society of Uganda. I want to appreciate AAPG Makerere University. I also want to appreciate and recognize Makerere Petroleum and Geological Society, and also appreciate and recognize Society of Petroleum Engineers, Makerere University, without forgetting the biggest of our organizing partner, that is Covelite Investments. Thank you very much. Without further ado, I want to just open up with a small abstract about today's session, and I want to see that all of us are at par, and those who are joining in, please feel free to engage as much as you can, such that we can get the best from this session. To open up the session, remote sensing and image classification looks at assigning classes defined in land cover and land use classification systems to all the pixels in an image or information acquired from a distance. The output raster from the classification exercises can be used to create thematic maps. Without even further ado, again, I want to welcome um, um, our I want to welcome Mr. Kasacha to say a word before he can open up direct to the facilitator of today, Madam Aisha. Mr. Kasacha, the floor is yours. You have very few minutes and we can go direct to the presentation. Thank you very much.
Okay, thank you so much, our moderator for the day and our facilitator together with our organizing partners. And good evening, everyone. I want to take this honor to welcome you all for this lecture. As it was promised that we should a more detailed lecture about remote sensing and raster data analysis here. So thank you so much for showing up, for having a wonderful session. So let me hand over back to the moderator. Our moderator. Hello.
Mr. Kasacha, you are not audible.
Hello.
Yes, we can now get you. Please go ahead, Mr. Kasacha.
Okay, sorry. It's very unfortunate that you couldn't hear me. Yeah, but I just wanted to thank our facilitator and our sponsors for this part. Then we can hand over to you back, our moderator.
Thank you very much, Mr. Kasacha, for that simple open up. Without any further ado, please let me welcome uh, Madam Aisha to take on. Madam Aisha, the floor is all yours. Thank you very much.
Good evening, everyone. Thank you, Mr. Wambi and Mr. Kasacha, for this platform. And I hope I'm with my people that I discussed with the other time. And if you're new, I don't know if you got the guidelines of how to get to know if I'm leaving you behind, how to get me back to your pace. So the request was that I take you through how you can download images from the site I shared. Mr. Professor, I'm going to ask you to stop sharing your screen.
Okay.
Okay. Um, can everyone see my screen?
No.
Yes.
No.
Yeah, we can see it. We can now see.
Yes, we can now see.
Okay.
Please go ahead.
So I am, yes, I'm displaying the USGS website. So you can follow what I'm doing. So what you do, you sign in if you're not yet signed in, but if you are, you just click on the website and you go right in. Yeah. And if you're logged, cancel. Okay. So when you sign in, it will come in like this. On top here, you're going to see different bars. We have the search criteria, we have the data sets, we have additional criteria, and we have results. So people are having trouble finding where to download, that download button is. Now, you're not going to get the download button until you specify clearly which images you're looking for, from which satellite, which dates, and all that. And you do that using these bars here on top. Yeah. So you will come, when you click on a bar, just go down here, scroll down, and keep specifying things that you'd want. So in this case, we are in a geocoder, or you can want to get KMLs and shapefiles, depending on what you're looking for. But I'm going to stay in the geocoder and keep it as a feature. And down here, I'll just, you can specify the feature name you're looking for. For example, you can put in Lake Victoria, or you can put in River Nile or Mountain Elgon, anything. But if you have a wildcard, you just click and put in a percentage sign there. Yeah. Then just keep these the way they are. Then when you come down here, specify the dates in which your images should come from. You can just click on that date here and look for the year. So you're supposed to give it a range. So if you're looking for an image that was taken around Lake Victoria in 1998, for example. So you'd come choose 1998, specify the months in which, now, how do you choose the months? Depending. Some months have a lot of cloud cover, some months, depending on which satellite that you're going to be choosing from, that satellite probably did not have images during that month. So if you choose like May, February, March, 18th, 1998, and you want only images in 1998, yes? So you come on the next image and look for 1998 again. But now you need to get a month that is past the one you first chose. So you can take May, June, July, but I'll take December to give it more, yeah. No, December 20, 1998. Any dates. So you see that has changed. So you go ahead to specify the next criteria, data sets. So which sensors are you looking for? Which satellites do you want to use do you want to pick your images from? There are a variety here. Aerial imagery, digital elevations. Are you looking for global field issues? And are you looking for land cover? Anything. So I picked images from Landsat. You can see it's still open there. And level 2 images. I'm going to explain why we are looking for level 2 images. So you can choose any radar, NASA, any vegetation monitoring, depending on what you're looking for. Please let me know whenever I lose you or whenever you can't hear me. Okay, so after choosing that, you go back to the top and look for another bar in here, additional criteria. So your Landsat, if you have any other things you want to put in here, and you can switch back and forth until you have exactly what you're looking for. Yeah. Then you go to results, and then it's going to look for results. You see, now for that months that I chose and the year, they don't have results for Landsat 8 and 9, level 2. So you go back to your search criteria and change accordingly until you get what you're looking for. So let me stretch it to this year to give it more time to, more space to, pick up more images. Dates. Okay. You give it time to look for the images. So when you look in the results here, you see we have different images, and it gives you the date at which the image was acquired. So this first image was acquired from 2017, 2017 December, from the path 016 and the row 25. Now, these rows and path define the areas where the image was passing. So you need to know which rows you're looking for and which path. So you go through them, you go through the images here until you find the one you're looking for. Most of them were picked in 2017 because Landsat 8 and 9 are very new. So if you want older images, you'd have to look at Landsat that is below 8. That is Landsat 4, 5, 3, 2. And then wherever you find the image you want, you come to this button here, the download button. You click, and then it prepares your download. It gives you an option of the reflectancy bands and the temperature bands. Now, your analysis defines which one you want to download. Yeah. So if you want the reflectancy bands, the reflectancy basically shows you, both of them can give you land cover, land use, but sometimes you're looking for maybe disaster, maybe fires, or you're looking for a hillshed or something. So you'll choose which one you want, and then you click on that and download. So this is how you download basically. So I'm not going to download. So anyone that would want to do that would download. That is how you download the image. Okay, someone needs to mute that person. So now, Mr. Kasacha, you can go straight to the presentation. I hope everyone has gotten that. Today's presentation, I'm going to be giving you the basics of how you can classify your remote sensing data so that it is ready for your analysis. Yeah. Next, please. So, to start with, what is remote sensing? What is this word that we are hearing about? So, remote sensing basically means that you're getting your data remotely without actually going physically to the area where your data is, but you're getting it from a distance. Next, please. Kasacha.
Okay.
I wanted to, there's too much about remote sensing. I didn't want to dive into that, but I wanted to specifically talk about the resolutions in remote sensing because they are very vital in how you're going to be choosing the images you're using, in understanding the image that you're having, in understanding the specific analysis you want to do, and how to be able to get the actual or the best images for the particular analysis you want to do. So the resolutions that affect or define or dictate how your images are going to look like is the radiometric, the spatial, the spectral, and the temporal. We are going to discuss that in detail in the next slide, please. And Kasacha, you can share this presentation in the chat so that everyone can have it later on. Next slide.
All right,
The
let me do
radiometric
that.
resolution means how much pixels. Yeah. Yes.
Yes, Madam Aisha, we
Kasacha?
can hear you. We can hear you.
Okay. So. Okay.
Yeah.
So in the radiometric resolution, is the amount of information, please go back, is the amount of information in your pixel. Yeah. So the more radiometric resolution, the bigger your scale. Yeah. The bigger your scale, the more detail you have. And the smaller your scale, that's the little detail you have, like you see in that image. So if your scale is big, for example, you want to get an image of a school, that is a large scale. So you're getting more detail. That means your radiometric resolution is big, and so you can pick up more detail. And if your scale is small, for example, you want to pick up the image of an entire continent, yeah, so that is a small scale that is giving you a low radiometric resolution, and therefore you're getting smaller details. Next, please. For the spatial resolution, this defines the size of each pixel. So if your size of the pixel is big, that means you're getting little detail. Yeah. So if the size of your pixel is around 1 kilometer by 1 kilometer, that means all the details in that 1 kilometer space, yeah, are being squashed and like minimized, so you can't actually pick up detail in a 1 kilometer area. So when you want more detail, you have to have a higher spatial resolution. That means your pixel size has to be smaller, up to 10 meters, so that you pick up the last detail, depending on which analysis you're going to be making. Next, please. Now, the spectral resolution is basically how many cameras you have on your sensor. How many bands that can your cameras pick up? Yeah, how many color on the electromagnetic wave? How many colors can be picked up by your sensors? Yeah, so that is also important. Otherwise, you'd get a black and white image, or depending on how much cameras you have on your. So you need to know that the Landsat that I'm picking, so the Landsat 8 has 8 cameras. So it gives you more spectral resolution, because it picks up more waves from the electromagnetic wave. Next, please. Now, the temporal resolution is how fast or how quickly or how much time does it take your sensor to come back to the position that it actually picked. So if we are monitoring a flood, for example, and this flood is going to take 1 week, you cannot use a sensor that takes 1 month to come back to the area where the flood is when it's going around the globe. Yeah. So you need to put the temporal resolution into consideration. So if you're going to be monitoring a fire changes per second. So you need to pick up a sensor that gives you a temporal resolution that is very small, so so that you can see the changes. But what if you wanted to pick up or analyze changes that are happening, for example, on Lake Victoria, how land use is changing within and around Lake Victoria. That can be monthly or after month or after year. So then that would define what sensor you'd be choosing from your images, depending on the temporal resolution. Next, please. Okay, so that's basically it. And that takes us to the point of data processing, interpretation, and analysis. When you get your images, when you finally decide on which sensor or which satellite you're going to be picking your images from, now when you get the images, what do you do? Or when your sensor picks up the image, what happens? This is what I'm going to be discussing today. Yeah. So when the data is picked up by your sensor, because we have passive and active sensors. We have sensors that pick up the image depending on the sun, on the light from the sun. Those are the passive ones. And then we have sensors that pick up images by producing their own illumination and then picking up the back scatter from the areas they send their things to. So when they get back these images, they undergo levels of processing, from levels from the 0 level to the 4th level. Next, please. I have detailed these levels in the next slide, telling you what happens to your image. So when you get your image at 0 level, that means we have it is not corrected to time, to the geography, the georeferencing. It has sun angle problems. It has it still, actually, those images are not given to the public. Those images just go to the base station, the owners of those satellites, to remove all the corrections, to make all those corrections before they can be availed to the geoscientists to use them. Okay, so why I'm putting this part in this presentation is to explain why I wanted one to download a level 2 image. Yeah, so when you download a level 2 image, that means your image is georeferenced. When you import it into your ArcMap, it will sit exactly where it's supposed to be. You won't need to actually georeference it. It also means that your image has metadata that is up to date. It can give you the time, the day, the weather, and other details, as we are going to see. Then it also means that your image is corrected for the sun angle and the other atmospheric corrections that are needed. Yeah. It also means that the radiometric corrections and calibrations have been made. That means you don't have a lot of work to do with your image before you actually start your classification. Because if you get them at level 1, if you get an image at level 1, that means you have to actually do physically the radiometric corrections, the sun angle corrections, the atmospheric corrections, the georeferencing, which sometimes doesn't go well. Next, please. Okay, so now that we have our images, we go into the image interpretation, which is classification. Some of the strategies you're looking for, I know this slide is crowded, but you're going to get this presentation and everyone will be able to read through all these details. But it's good to know the scale of your image. You need to know the scale of your image. So when you know the scale of the image, you can predict how much detail you're going to get out of that image. Do not pick up an image of an entire continent and then you want to know what is happening in Kampala, for example. That will not be able to give you detail about that. That means you have to check your scale. Then you have to look at patterns, shapes, and textures, because every other feature on the surface of the Earth behaves differently. Vegetation reflects the electromagnetic waves differently. The surfaces like the roads, the bare land, the rocks, the rough terrains, all of that reflect light differently, which means they will be giving you a signature and you will be aware that this pattern is a signature for this particular class. And when we talk of color, it's good to know your colors. That is why we talk of the false color composites, and we talk of the true color composites, because when you talk, for example, when you talk of the NDVI, you need to know your colors properly so that you don't make wrong classification. You don't see a green and because it's in a false, you don't know if it's in a false color composite, and then just quickly think it's a vegetation. you'll be making a lot of wrongs in your classification. And also, you need to consider what you know about the area. And that is also very important in classifying your classification, whether it's useful or unuseful. Next, please. Now, that brings us to the quantitative analysis of classification, which describes the types of classifications that we can do on our images. We can do unsupervised classification and supervised classification, but we can also do image-based classification. What are these things? I'm going to be explaining them in the next slides, please. Next slide. Kasacha?
Yes, I have changed the slide. Is it changing on your side?
Okay, it has changed. In here, I try to explain or to visually show you what I mean by these different classifications. We have the pixel level classification, which is which uses the classified and unclassified techniques to do the classification of the area. But we also have the object level, and these are good in high resolution images like the ones you're seeing now, because object level means I actually identify that this is a tree, this is a house. Yeah, that kind of classification is good in high resolution images. But we also have the scene level classification. In a scene level classification, you're basically not telling us that this is a house, this is a road, this is no. You're looking at everything together and telling us that this is a school, this is a market, this is a harbor, for example. Yeah. So this is a detail of how the levels of classification can happen depending on your at the end of the day what you're going to be using your image after classifying it for. Next, please. Okay. So unsupervised classification. In the unsupervised classification, we are going to be looking at these practically, but I wanted to talk about them because I need people to go into the software when they know the science behind what we are doing. So if the unsupervised classification, this is still pixel based. So we are classifying each pixel. Yeah. And in here, what we do generally is just you identify the clusters that you want. Yeah. And then assign those clusters classes and then just let the software do the classification for you. You don't do any work in here. All you do is open up the classification window and tell the software to classify your image in a given number of classes. You can say, I want you to use this image and classify it in 5 classes as specified in the LULC classification protocol. So after that, name those classes, the 5 classes, and then let the software classify for you, and it will do it quickly. Next, please. Yeah, this is basically explaining what I just said there. You get a class, you create clusters and then identify the number of groups you want to generate, and then let the software do it for you. Next, please. There are different techniques the softwares use. There are k-nearest neighbors to try and understand how to pick up different pixels and cluster them together depending on how you have described them. I didn't want to go into that because that's another thing. So this brings us to the supervised classification. Now, under the supervised classification, how it differs from the unsupervised classification is that in here we have to create training sites. manually. So you go into your image and create training points. You're giving the software a reference point. You're telling the software that use these references that I'm clicking on and then specify the entire image depending on what I've just given you. So if you create a polygon and say this polygon should be classified as vegetation, this polygon should be classified as a built-up area, this polygon should be classified as water body, then tell the software use that to classify the rest of the image. So the more the training sites, the better classification the software is going to use. And you have to be careful. It takes a little bit of time, but this is actually what you're going to be doing today. Next, please. This is explaining what I was talking about and specifying the kind of classification techniques, algorithms that you can use under the supervised. We have the maximum likelihood, we have the principal component, which is nice, and we have the support vector machine, which is the trending one now. So if you're going to be using this supervised classification, support vector machine is the in thing right now because it doesn't do any errors. It doesn't give you any error matrix. Next, please. Okay, that brings us the object-based image classification, which I was explaining earlier on. And just here to break it down for you is that you have to perform multi-resolution segmentation, then also go ahead and select training areas, just like supervised, but just now this time that you can actually see the features. And also, if your resolution is very good, the software goes ahead to digitize out these features for you. Yeah, define the statistics and then classify. Next, please. And this is explaining that, yeah, that thing. Next, please. Now, the question will come up. So when should I use the pixel best, which is the supervised and unsupervised? And when should I use the object-based classification? Next, please. Now, we use the supervised and unsupervised classifications in images that have very low spatial resolution. Yeah, so you cannot really tell the difference between or the boundaries between these different features. So those classifications would be very good. But in an image where you have features that are clear, very high spatial resolution, then it's good you go with the object-based classification. Next, please. And after classifying your image, that will take you into your image analysis, and that can be broad from disaster preparedness or environmental components, or you're looking at a hillshade flood areas, depending on which, or you want to just do a change detection. So that is all going to be dependent on which analysis you're going to do. But basically, the classification goes the same way for all the